Good morning, everyone. We're going to be working today. We're now on week number 5 on the time value of money. So, time value of money, it's actually, there's a lot of math, but it's a simple math. It's not too crazy math. So, we'll try to do it. We'll use the PowerPoint, and then I created extra exercises so we can show you how to do it manually, how to show that you can prove that it's correct, and then how to use the Excel function, right? So we have a couple of ways. In your exercise or your quiz, you would see that most of the formulas are, you can use the Excel formula, but we want to make sure that you understand how to do it manually. So, any which way, either you build a financial statement or a forecast or a projection that would use time value of money as a concept on a long cut method or a shortcut method, because some of them visually you might want to see it. And as we go along on a later chapter on capital budgeting or capital uh, budgeting decision making, then we would actually use some of the concept of the time value of money to show or to calculate net present value. So we're trying to now to build up concepts in a later topic. Then basically those topics are the core topics that you would need when you graduate and then use finance in the business world. Now, in the time value of money, let me make sure that we have a background, right? It's either a question of what is the value of the amount, so the present value of the amount that I actually need to have in order to get something in the future. Or it's something that what do I need to have now, or what is the value of the future if I make an investment on the now? So that's one thing, right? A present value concept and a future value concept. And then that can be an occurrence of one time. I'll make a placement on an investment bank funds, maybe investing on a ETF or a index fund. And then that one placement right now, one big lump sum of money, how would it look like 10 years from now? Or that's one occurrence, a single factor. Or it can be if I contribute to that investment fund, would say with an investment bank every year or every month or periodically, consistently all throughout, say 5 years or 10 years, what will be the value in the future? Or a question of, hey, you know what? I'm gonna be doing. I won a jackpot, and then I was given a an option of getting a fixed amount of money every year, or do I get a lump sum? So it's the same concept, right? If I get a lump sum now, what is the value of that compared to? Is it better compared to getting a fixed sum for the rest of my life for 20 years? So you actually look on the value of the now compared to a lump sum an amount that you would receive in the future consistently, one fixed amount. So one fixed amount in the future is called an annuity. And then one transaction, a single occurrence, is actually what we actually have as two contrasting point of views on a present value and a future value. So in a way, four things, right? A present value of a single amount, a present value of future cash payments that can be done now. That's why it's a present value, or a future value of one time investment. See how it happens after 10 years, or a future value of a consistent contribution to an investment account for the same amount, an annuity, right? So those are the things that we would actually be looking at right now. So we'll go with the concepts first, and then from the concept, I'll pull out an Excel file, and then I'll post the Excel file also to so you can actually practice it. And then what you can do on the Excel file is that go through the exercise. The solutions are linked. You can actually see all the formulas and then practice using the formulas as well, or reperform it. Let me go to the slide deck. I'm going to go jump into a future value of a single amount. Let me use the pen here. So future value of an existing amount, what we're trying to do is that we're trying to measure a value of an amount to grow at a given interest rate over a period of time. So we're going to be using this as an example right now, this formula, or let me just make sure I move it here. So an investor has $1,000 and needs to calculate its worth after 4 years at 10%. So interest, or I, is at 10%. 4 years is actually your N, meaning the period of time. And then 1,000 is actually your present value right now, because you're going to make an investment now. So that's the present value of the amount. And then you want to compute the future value. So we're going to be doing a lot of, say, acronyms right now, easy to follow. Just bear with me for that. And then we're going to use the formula. So when you think about it mathematically, um, on the first year, you have $1,000. That's your investment, right? And it's going to earn 10%. So why do I have 1.10? Because the base, or that 1%, the base is 1,000. If I do 1.10 is similar to 1,000 multiplied by 10%, which is $100, and then add again the principal of 1,000. So making it shortcut, it will be 1.10. So that's why you would see 1.10, or basically this one is 1 plus I. So let me just make sure I type it there so we have it for reference. And so this one is similar to the formula of 1 plus I. Okay, that one is similar to this one. So 1,000 right now on the first year, and then you have 1.10. So it's going to be at the end of the first year, you're going to have 1,100. What does it consist of? It consists of two things. The principal is actually 1,000, and then the interest now is basically 100. So your balance at the bank right now is basically 1,100. Okay. So now when you have 1,100 at the bank, what happened now is that on your second year, so your beginning balance is 1,100, right? That's why it changed. You have the 100 here. Then it earns again because you never withdraw, you never take out the money. It's like it's a single placement. That's why we call it a single amount. And then you would like to see what's the impact after 4 years. So it's 1,210. Same amount here goes into the third year. So 1,210, same interest rate, 1,331. At the fourth year is 1,331 beginning balance, and then times 1.10 is actually 1,464 and 10 cents. So you computed a fair, a future value of an amount of 1,000 for 4 years at 10%. So what we were going to see later on is that what if you do 20 years? What if you do 15 years? So you don't want to do a long calculation. That's why we wanted to see what's the best way of calculating it using a function, right? A math function. So the math function that I was talking about can be summed up with this. So basically, in order for you to calculate the future value, we say that the present value, you know that present value is basically the 1,000, right? So that's 1,000. And then I would actually have 4%. And then that will, oh, sorry, it's actually earning 10%. And then the N is actually 4. Okay. So let me make sure that the I, or the interest, pertains to this one, and the N pertains to this one. So instead of you multiplying by 1.10 and then getting that balance again, moving into the second line, and then multiplying by 1.10, you can put it as a power, right? An exponent. So it's by 4 years. So the formula now would be to the fourth power 1.10 and then 1,000. And then if you multiply now, after you get the factor for this one, which is 1.464, multiplied by 1,000, you get the same amount of 1,464. So it's a better way of calculating compared to doing it this way, right? It's the same amount, 1,464.10, and then that's the same amount there. So that's why the first thing that we're going to be looking at is actually this formula. The future value is equals to the present value multiplied by 1 plus um, multiplied by 1 plus I to the nth power. Okay. Now, in your book, you have at the back, most of the finance textbook, they have a table at the back. It's just that in case that you do not want to calculate it manually, you can take a look on the appendix, and then it would show you how to actually calculate also. How do you use this one? So I'll just show you, but normally you can use an Excel function, but just in case that you want to do a quick glance, you can actually use this one. So on your appendix, what you do is that you would see that there will be a formula, right? And then you need to understand whether it's a future value of an annuity. Right now, it doesn't have an annuity, right? Because annuity would actually be an AFBA. So it will be there, something like that. But it's not like that right now. So I know it's not an annuity. It's a one-time placement, as we saw a while ago. 1,000 starts in year number one, then you never touch it until year number four. So it's a one time. And then you will see also the formula here. So what do? You take a look at the number of periods. We know it's 4 years. And what's the interest rate? We're actually looking at 10%, right? So in between that is actually our 1.464. So I can get this amount and then multiply by 1,000, then I'll get the future value without doing the fancy math, right? But sometimes the challenge with that one is that what if I have something in between? So 9%, you can technically do some extrapolation if you would like to do that, but it will be just better to use an Excel function or even the long method. So normally these are appendix on your book or any finance book, or sometimes you can Google it and then look for tables on future value of a dollar. If I say a dollar, because basically everything is just you can multiply it directly. Okay. Now think about it this way. So now we have a present value of a single amount. Let's do a reverse. I'm going to go back to our simple math formula, right? So on our simple math formula here, or a longer method, the present value of a single amount asks you, okay, I have this amount that is my target. Think about it as like an amount that you want to say pay out in the future, just or withdraw in the future, right? I want 1,464 in the next 4 years. Like, but and then I'm thinking that the market rate is actually 10%. So what do I need to do in the now? So when I wait by 4 years, I will actually get 1,464.10. I know it's a bit exact, but bear with me with this one. So if you have an X number, which is right now is 1,464, in the future after 4 years that I would like to actually see, knowing that the market is doing at 10%, what's the amount that I need to invest now? So basically, we're solving for this one. So what do we have? Let's make sure we tag it. This is the present value, the 1,000. This is actually the future value, right? A while ago, we were competing for the future value, but this time around, it's reversed. We want to compete for the future value. we know before it's the present value multiplied by 1 plus I up to the n power. So if we do the same formula, if we actually cancel it out right on the equation, the formula now to compute the present value of a single amount will be the future value multiplied by basically just that 1 over 1 plus I to the nth power. Or when you think about it, future value divided by 1 plus I to the nth power. Because the formula to get the present value or the future value is actually present value multiplied by 1 plus I to the nth power. If you just reverse the equation, then to get the future value, just divide it by 1 plus I to the nth power, or multiplied by 1 over 1 plus I to the nth power. And instead of me just saying that, let me make sure I can type it right. So future value is basically, or present value, basically future value multiplied by 1 over 1, 1 plus I to the n power. I'll just do caret n so you can see it, right? And then because we have that, I want to make sure I have that one. Or, and then let me type it in. Present value is actually to future value, and then divided by 1 plus I. I'm going to do caret is the exponential function in Excel, right? Because I don't have a superscript here. It basically did not do well. Oh, I think I can get rid of. So it's the same expression, which is actually the same expression as this one. It's just like a bit linear. So right now, what do we have? It's 1,464 and 10 cents, as we know from our previous calculation, multiplied by 0.683, which is actually what? It's actually 1 plus I, which is actually a 10% to the fourth power. So that's why we got that one. So now we know that 1,000. So we go back to the 1,000 here, which is basically what we got on this side. We started with 1,000. So you can see that you can do it both on a from present to future, then return it back, right? So that's the beauty of it. Just the same formula of a single transaction. Same here, you now have, instead of a future value, a present value of 1, no annuity, because it would actually have a letter A here, a subscript. So annuity, which we will discuss later on, will be looking like this. It will be PV and then do this one, and the letter A on the bottom, something like that. It will be a subscript. So right now it's not, so I know it's actually a single transaction. The way that we look at it, I have it in 4 years, period, right? So I'm going to focus on here, and then I'll look for 10 years, 10%, which is my interest, the I. And then the cross section between the two is actually my multiplier, right? So the multiplier, because it can be, like a multiplier of 1 over 1, 1 over 1 plus I to the n pounds. Okay. Now, this is actually a graphical representation, right? Here's your dollar on your Y. You start from 0. Here's 1,000, so most likely it is 500, 1,500, say 2,000. Right? So you start from 1,000. That should climb across in 4 years with an interest rate of 10%. On the fourth year, you will get 1,464. And then what is that? That's actually the future value. This is the present value. and this is actually your N, and this will be your or your interest rate, right? Yeah. So it's an easy way of doing it, and then now you can do it both on a formula-based calculation. And then I can do, what's the future value? Future value is actually present value multiplied by 1 plus I, 2D, and but I would actually need to make sure, sorry, all right, there you go. And then if I want to get the present value, it's actually the future value multiplied by, this is where I need to type it in, 1 over 1 plus I to the nth power, right? We use this a lot. So in practice, I use this when I calculate. So so when I calculate a retail site, what do I do with this one? So I just want to make sure that you have some practical application, right? In Guam, we've been trying to build new gas stations. And then, so, interestingly enough, what happened is that we have one guy, right? So we have my coworker, Marco. So what he does is that he actually goes to the intersection of a lot that we're looking at to build a gas station. And then he has a one of those things that flight attendants use to count the number of passengers. So when they greet you, they have somebody on the back, like basically punching it, and then number one, number two, number three passengers. So it's the same thing as what we do. So my coworker Marco goes to the intersection of the plot wherein we want to actually look on to it if it's profitable to build a gas station. So he has the counter, and he will count the number of vehicles, right? He will count the number of vehicles that would actually make a turn on that location, either on the opposite side of the road or on the same road. So the question is that a good location wherein people will gas up, regardless of the direction of the road? And then he has a worksheet. It's a methodology by Shell that he would count it, and then he would categorize it based on the number of cars. Is it an SUV? Is it a truck? And then he would do it on random times, random and specific times during the week per day to know whether is it busy on a weekend? Is it busy on a weekday? Is it busy during the morning time when there's a morning rush? What about midday? What about when you gas? So people gas up in the morning, they gas up before going home, and then they gas up during lunchtime. So that's what we always see, right? So he calculates that one, and then he will give me, okay, Jason, here are the number of vehicles, and the calculation will be every month there will be this much gallons of potential fuel, right, that people are gassing up. So what I do is that I will forecast the profitability in the next 15 years, and then I would use the time value of money. In the say in the 15th year, it will be say 30,000 gallons per year, for example. But by the 15th year, it might be say 45 because I have a growth rate. And then I would say that say profitability multiplied by unit margin. And then if I get the total amount, then that's my profit margin on the 15th year of having that station. But I know that on the 15th year, it's a different value if I look at it on the now, right? So if I look at it on the now, I will multiply it with a present value factor. So what am I trying to say? In the future, I have the number of gallons. So basically my sales quantity multiplied by my unit margin or gross profit. And then that will be a dollar amount. That's the future value. But I need to multiply it with a factor because I want to compute it in the now. I will discount every year the 15 years to the now. Basically, that's what I'm doing. I'm bringing it back to the now. Why the now? If I'm spending money to build a site, I would spend it in the now. And the future value or the future income is 15 years. So I'll bring it back to the now, wherein the value of a dollar is a dollar minus how much the potential revenue, then that would be my profitability considering the time value of money. So it's a very esoteric discussion. I know I'm just like doing it by voice, right? But later on, when we go to week number 10, we will do now a calculation. And then that is actually a skill set that not a lot of people actually do, right? When we compute for the internal rate of return, the net present value, and then the payback period. So I've seen that a lot of folks in practice, when you graduate, they do business development, but they are not able to do calculations like that. So accountants are being asked to do that. And then it's important skill set when you go to the board of directors and then say, hey, I need $3 million worth to invest on a retail site because it will create a internal rate of return of this much, which is basically growth for the company. And then it's based on this model. And then you're gonna see there the time value of money, the formula that we're using here, or we're showing here, as part of a bigger calculation. So I wanted to give you that, so at least you're not just seeing this one on a theoretical point of view, but we actually use this in practice. Okay, let me clean it up. And then I know I'm going to see and then I'm going to do an interest rate. So last one before we go to annuity, right? But I'll go to an Excel file exercise with you. Now, sometimes you know that, hey, I want 1,464.10 in the future. And then I know I need to invest for 4 years. Well, what is and then the money that I have right now in the now for year one is 1,000. So basically that's our premise right now. Let me type it in so we can see it also. I know I have right now $1,000. And then what I'm targeting is that I want to have a 1,464.10. I know it's a bit specific, but bear with me. And I only have 4 years of time to make an investment of that $1,000. And then I'm hoping I'm gonna get this one. I'm trying to look for banks that would offer an interest rate that would actually be good. But what is my starting point for the interest rate? So that's why this formula, which is which is derived from our formula before, is the way to calculate the interest rate. Because you might be seeing banks, hey, I'm offering 5%, I'm offering 6%. Is 5% enough? Is 6% enough? And then this will be the formula. So I'll end with, well, I'll not end. I'll stop with that because we're going to go to an annuity calculation, but I'll show you an exercise. Yes, we're going to go to an annuity. So I'll move my Excel file on the screen. I have two screens. If you see me looking here, because I have a screen here. There you go. So I'll post it. I'll post it on Canvas, and then I have a couple of problems that we're gonna go through, and then you stop on the gray side. See how we can name it. So let me. Hopefully, you can see it for now. Because if I make it bigger, I will not see more than line 29. So let's do it this way. I'll do first both the present value of a single amount and then a future value of a single amount. I put the formula here so we would always remember it. Okay. So we'll do first a hypothetical, hopefully relatable, a problem. So you are planning to buy this car, a Honda Civic sedan LX. It's a 2025 one. I went to our website in Guam. And then, so when I saw it, okay, it's 29,000, about 30,000, $3 short. Um, the recommended price or sales price is 31,523. And then there's a discount. Things are a bit expensive in Guam because depending on where the Honda factory is, either it's actually from North America, then it goes to Guam, so you normally have a $3,000 shipping cost, right? Um, Interestingly enough, if we buy a Mazda, we actually pick it up from Fukuoka, which is not too far from Guam compared to North America. That's why it's a bit cheaper by say 3,000 or 5,000. And I'm thinking that's actually the freight cost, right? So they don't incur the freight cost. And of course, if you're buying it from the Fukuoka location, you're most likely the trade is actually in yen. And then yen has been good as high as 160, and then now it's actually trending to 140. The Bank of Japan actually increased the interest rate. It's a different topic, but interestingly enough, those are where economics theory lines up with finance, that lines up with accounting. And then as a business major, those are the things that should, well, like things that interest the mind, right? Theoretical side, how does it apply? How does it impact you? Now, going back to our hypothetical problem, you're planning to buy a car, say when you graduate or later on after 1 year of working, uh, 5 years from now. So you have 5 years, and then you expect that the car would cost 33,000 because right now, hey, you know what? Right now it's actually about 30,000, but maybe in the future, yeah, it's going to be 33 for the same um, Honda Civic sedan that you're looking at. You want to know how much money you need to invest today to have that 33,000 in 5 years. And then you're expecting an investment rate of 5%. Now, I went to online just to make it as realistic as possible, right? I went online yesterday, and then I went to US News. I looked at Vanguard. Vanguard is one of the investment banks wherein you can place money and it will grow through a ETF or mutual funds, depending on or an index fund, depending on what type of investment that you want. So I was looking at Vanguard, the corporate bond, then it actually had the 5%. So I said, okay, let me use that as a benchmark because the Fed recently cut the interest rate. So wanted to make sure it's as realistic as possible. So it's a 5%. So now we have the setup. In the future, this 29,000 or 30,000 will be 33. I can make I can make an investment in the now, and then in order for me to get 33,000, what I'm expecting is the price of the Honda Civic in after 5 years, but using and making that money placement to the now in a Vanguard total corporate bond. So future value 33,000. The mutual fund from Vanguard at 5%. How long do I need? 5 years. So what is the amount that I need to place today to the Vanguard total corporate bond? So basically, what we can do, I'm going to make it a bit big, guys, okay? So you can see the formula so it's not too hard on the eyes. And, and let me clean up. Your formula would be the present value multiplied by 1 over 1 plus I to the n power, right? This one, which is actually, it's going to look like this. If you do the math in Excel, but you do it like as a typing a formula, then that's how it's going to look like. If you want to do it by hand, or meaning a long cut method, not by hand but by Excel, it's going to look like or you want to do it in a formula in Excel, it's going to be using a equals present value formula. So the formula syntax is actually equals present value. Let me make sure. And then the first syntax is actually the rate. So the rate is I-22. So I-22 is the rate. And then if I do this, I'm gonna lose out on. I know, guys, okay, I can do it properly. There you go. So we'll do it by color. I-22, the first one, is the interest because that's the syntax on the Excel, right? A function. So I-22, the cell is 5%. Then I link it up. Then you do comma. So it's now asking you what is the amount that you need to actually the number of periods. NPER is the number of periods, right? So it will be in red I-24, that's 5 years. I'm gonna move it a bit, guys. Okay, so bear with me if I actually make it a bit smaller, because now I want to show to you what is the meaning of each one of the Excel formula here. Okay, so that's what I was trying to do. I-24 is actually I, and then 24 is the 5 years, and then I-24, which is actually this one. Let me make sure I clean it up. I-24 is the 5 years. And then I-22, which is the rate, is basically the interest rate. And then I skip so basically you see one comma and then one comma. Basically, you skip this amount, and then you just basically go to the future value. The future value is actually the 33,000. That's why it's actually I-20. And then you can see also that there's a negative, right? There's a negative there. Because you want, if not, you're going to show a number that's negative. It's going to show a number that's negative, so you do a negative to actually multiply. Negative multiplied by negative is equals to positive, right? Because it's actually a future value. You would see that on a lot of the formula. I will do it here. I'll press F2, or you can see it on the function side here. I like to press F2 because you can see the color, right? And then the color highlights here. So the answer is that in order for me to get 33,000 after 5 years with an interest rate of 5%, if I make a placement to the Vanguard Total Corporate Bond, I need to make an investment now at 25,856 and 36 cents. Basically, that's what we're trying to do right now. Now, I can do this on a long cut method, right? Or a long method. I should have used long cut, right? Because it's shortcut, but not long method. So it's a long method calculation or by using the proof. And then the proof is basically your amortization schedule or doing it a long way, right? So I have 25,000. I'll start with the answer. Is the answer correct? Did I mess up with the formula? So 25,856. There are no additional investment because it's only one time, single transaction. And then now what happens is I will multiply it by 5% to get the interest. And then now I have the balance. I'll just add across. The initial investment of 25,856 plus the interest at 5% that you earn at the end of the year, that will be 27. Now, the interest of 5% would actually be applied to the balance as you go through. And then the balance now is basically adding prior year plus what you have earned as interest using the balance that you have as a running balance. So by the time that you go to the fifth year, it's 33. So that's why you know it's actually correct. It went back to 33. By investing 25,856 at 5%, you actually get 33,000. So I hope that helps with a formula. In the quiz that I'll post on Canvas, you will be working with you would actually have one cell, right? Say, hey, give me the solution for here. So it would mean that you would be using the equals PV function. How do I do that? It's actually here, equals PV. Then open it. It's asking for the rate, 5%, comma. It's asking for NPER. Actually, I can highlight that. If I click that one and highlight, it goes to a. I'm looking for my screen now. Where does it go? Because it might go to a browser. And then it would show NPER. I know that's actually the number of periods NPER. So I'm going to 5. Then I'm going to skip the payment because I don't have the payment. So I'm going to skip one more time because now it's engaged to FB. It's the future value. But I'm going to do minus negative 33,000. I'm going to skip the type. There are two types of payment. You can have annuity and then ordinary annuity and end. We're actually going to skip that because that's a higher level finance, some calculation, but understanding that it does exist is good. I can cut it by doing a bracket. It means that I'm not going to include the syntax or the last syntax of the Excel function. And the same thing, 25,856. So it's easy to do it in Excel, but I would want to make sure that we understand how do you actually craft it, right? Um, Sometimes you just like do, oh, I know this is how you do it, but the logic behind it is hard. So that's why it's hard when they reverse the concept. I would want you to actually be able to follow through and apply through. Okay. Now, what we did, I have one more topic, and then after that one, I'm going to cut the video, and then we're going to go to the annuity on another video, just to be sure that we pace ourselves properly. I'm going to go now to a future value of a single amount. Now, we're not going to do the same car because we can do it basically reverse, right? We can actually do it on a different topic. So I'm going to move it here. So now, let's say you are getting a graduation gift of 1,500 from a relative. And instead of spending it right away, you decide you want to invest it in a savings account that would earn an interest of, say, 5% in the year per year. You want to know how much the money will grow in 5 years. So it would earn interest. You would neither take out the principal amount nor take the interest. You're basically, hey, graduation gift 1,500, let it grow, and then I want to see it after 5 years. So how does it look like? The formula that we have is actually you're computing for future value, right? What's the present value multiplied the amount of 1,000, the present value multiplied by 1 plus I to the nth power. And then what is our n? It's 5 years. Our I, 5%. Our PV, our present value, is 1,500, the graduation gift. And then we're computing for the fair value, which is the unknown. Now, when you do it in Excel, not using the formula or not using the function, it looks like this. Make sure I can show it to you on the bigger screen. Anyhow, guys, okay? You can actually do it that way, but make sure that the operations, the rule on brackets and whatnot, because you might mess it up. You might not have the proper calculation. You compute inner, and then you actually have the rules of operation. And then if you want to calculate that way, that will be 1,500 multiplied by 1 plus 5 to the caret fifth power. If I want to compute in Excel, remember equals PV before. Now it's actually FB, but it used the same operation. It's the rate, NPER, and then instead of the future value, it's now PV. And then you skip the type, right? So I skip this one and I skip this one. That's why you can see that there's two uh, commas there because you skipped the PV, the payment, and then you went to the present value plus a given, which is 1,500. From there, what you're gonna get is actually the same amount, 1,914. What does it mean? If I make a placement of 1,500 right now, in the future, after 5 years at 5%, it would earn 1,914. Let me do a proof, right? 1,500, 5% multiplied by 1,500 is 75 bucks. If I add across, 1,575. Now my new balance for second year is 1,575 multiplied by 5%. I got $78.75. I would add 1,575 from year one, 1,500 of principal plus 75, plus what it earned at the end of year two, because I'm not taking the money out. And that you go through is 1,914 is the same. Okay? Then I'm going to show it to you by hand, or not by hand, sorry, by computing it using the formula FB equals FB bracket. Rate would be, sorry, the rate is 5%, comma, NPER, which is the number of periods, is 5. I don't need the payment, I'll skip it. The present value, I'll do minus, then the 1,500. I'll skip the type, I'll do a bracket, enter, same amount. You just want to make sure that you can actually see it on Excel formula function, and then basically manually typing in the equation, and then also by proofing it. Okay? So now we have finished both the future value and present value of a single amount. We will go to the topic of annuity calculation, and then I'll end this recording, and then we will see you on the next video.